Okay. Our objective today is that we're going to learn the importance of valence electrons and how to draw Lewis dot diagrams. So by the end of today, you should be able to answer our essential question, which is, what is the location of an element on the periodic table? Tell me about its valence electrons and reactivity. Now, we sort of already talked about valence electrons when we were drawing our atoms, right? So, who remembers what a valence electron is? Okay, Xavier, what's a valence electron?
The last round electron count.
Okay.
How many electrons are on the last electron count?
Okay, very good. Antonio, can you repeat that or add to that?
It's how many electrons are on the last electron shell in the column.
Okay. Eliana, can you repeat that or add to that? Okay, very good. So, and that's what valence electrons are. Valence electrons are just the electrons on the last energy level of an atom. Okay? Very simple, that's what they are. So we already talked about. Now the reason that these electrons are, I guess, more special than the other ones, and they actually have a special name, valence electrons. They're still electrons, they're still negative, they're still on the outside, but they're a little bit special because these electrons are responsible for reactivity and bonding. So now, we already talked about the elements. We talked about how they are the parts of them, the subatomic particles. We talked about the charges within their particles. Now we're going to look at how these atoms are joining other atoms. Because what we're going to see is that every single element on that periodic table, except for elements in group 18, actually are not bound by themselves. They are always bonded to something else. And the reason they're always bonded to something else is because by themselves, we consider them unstable, meaning that they're not happy. Okay? So most elements on the periodic table are stable or happy whenever they join with another element. Now, we're going to see that the ones in group 18, which are also called the noble gases, those are stable. So those are the elements we find by themselves. So every other element on the periodic table we always find bonded to something else. Group 18 is the only element that we can find the atom just by itself, because they are stable and they don't need to bond with anything. We call those unreactive. So let's look at this word reactivity. Reactivity is basically how easy does an element react with another element or another compound. So when we think of reactivity, we consider the elements in group 18, and guys, this is very, very important. Group 18 is considered unreactive, meaning they do not react because they are stable. Okay? So the elements in group 18 are very, very special because those are the ones we find by themselves, and we find them by themselves because they are unreactive, meaning that they are stable. So, Jose, what do we need to remember about elements in group 18? They're not reactive because they are what? Stable. Very good. Okay? Mariana, what do we need to remember about group 18? What? Because they're stable. Very good. Eric, what do we need to remember about group 18?
They're reactive.
Non-reactive. Why? Because they're stable. Okay? Hanar, what do we need to remember about group 18? And they're not reactive. Why? Because they're stable. We just repeated that 5 times. Do you think that's important?
Yeah.
Okay, so you better make sure you have it written down. Group 18 is unreactive, and the reason it's unreactive is because they're stable. Okay? And they're stable because of the number of valence electrons. Because valence electrons are responsible for that reactivity. So, let's look at valence electrons in our periodic table. When we talked about the periodic table, we said that elements within the same group have similar properties. Remember that periodic table of fabric? Okay, it was the same color going down because it was in the same group. They have similar properties. And they have similar properties because they have the same number of valence electrons. So the valence electrons are responsible for the properties of an element. And those properties talking about chemical properties in which, how do they react? So if we look at the periodic table, we're going to see some patterns because it's periodic. And remember, periodic means a pattern, something that cycles through. So if you look, I kind of drew the first three periods, the first three rows of the periodic table, and that includes only groups 1, 2, and 13 through 18, because we have groups 2 through 12. Now the reason that I'm not putting in groups 2 through 12 is because those do not follow the pattern that I want you to make sure that you know. Okay? Periodic means it has patterns, but there's always exceptions for different things. So, what I want you to look at is I want you to look at this pattern that we truthfully already discussed in the past. Okay? So, Juanita, looking at that, what is the pattern of the valence electrons to the groups?
Each one, there's 4 valence electrons.
Uh-huh.
Group 2, there's 2. 13, there's 3, 4, 5, 6.
Okay, very good. So, if you look, group 1 is 1. Group 2 is 2. Group 13, if you take that 1 off, it's 3. Group 14, take the 1 off, it's 4. 15, 5, 16, 6, 17, 7, 18, 8, except for helium. Helium only has 2 electrons, so obviously it's not going to have 8 because it only has 2 in the first place. Okay? But basically what we're going to see is that in group 18, the reason they are unreactive is because their last outer shell is considered to be full. Having 8, or in helium's case 2, the outer shell is considered to be full. Think about it. In the first energy level, we can put up to 2 electrons, right? So helium, can you put any more on that first energy level? No, because it only has 2, right? And you can only put 2 on that first energy level, that's why it's considered full. In group 2, I'm sorry, in period 2, it has 2 energy levels. The second energy level, you can fit up to 8 electrons. If we look at neon, it has 8 valence electrons, so it's considered full. In period 3, you have 3 energy levels. In the third energy level, you can put 8 electrons. So then it could be considered full. Now, then you're going to think, whoa, wait, miss, you said that on period 4, for the fourth energy level, you can put 18. So it wouldn't be full. Reason for it's still considered full is because I gave you the simple version of how to draw an atom, but truthfully, that fourth energy level has what we call orbitals, okay? It has like sections. So that fourth energy level is actually divided into like 4 different sections. The last section has 8. So it's still considered to be full, okay? But I didn't want to bring that in because then you need to learn s orbitals and p orbitals and all that stuff. So we don't have a lot of time, so I kind of bypassed that, but whenever you get to chemistry, you're going to look at that. And you will see why we still consider krypton, xenon, radons to still be stable because they have 8 valence electrons. Okay? All right. So any questions up to this point? All right. So now, let's think. Group 18 is unreactive and is stable because it has a full valence shell, meaning it has either 8 valence electrons or 2 in the case of helium. Okay? So these are unreactive, meaning they do not react because they have 8 valence electrons specifically. So if these are not reactive, then what can we say about these? They're very reactive. These are not reactive at all, which we would consider least reactive, right? And these would be very reactive because they're the farthest away from that, right? Now remember we had some patterns on the periodic table. And we saw that melting point and boiling point, melting point, boiling point, increased or decreased from left to right or right to left, correct? Reactivity is the same way. So when we look at reactivity, as I go from left to right, my reactivity decreases because these are my most reactive and these are my least reactive. If I move from right to left, then my reactivity increases. Once again, because these are more reactive and these are the least reactive. So, Aaron, which group is the most reactive?
Group 1.
Group 1. Okay? Why?
Because the reactivity increases from right to left.
Okay. And what makes them reactive? What is in charge of reactivity?
The valence electrons.
Valence electrons. And how many do they have?
1.
1. Okay? So because they only have one valence electron, they are the most reactive. Alright? So David, can you explain to us why group 1 is the most reactive? And how many do they have? 1. Very good. Okay, Maria, can you tell us why group 1 is the most reactive? And how many do they have? 1. Okay? So the least amount of valence electrons you have, the more reactive you are. Okay? So, Juan, which group is the least reactive?
8.
Well, the group,
18.
18. And because it has how many valence electrons?
8.
8. Very good. So, we consider this group, very important guys, we consider this group the least reactive because it is stable, right? We consider this the most reactive, and if this is stable, this would be considered unstable. And truthfully, everything from here to here is considered unstable. All of them are unstable because they react. All of them are reactive. This is less reactive than that one, but it's still reactive. This is the only one that does not react at all. Okay? Group 18, very important, does not react at all with anything. These are called the noble gases. Write that down. It's called the noble gases. Now, easiest way to remember this, if you ever pay attention to social studies. Okay? The nobles in social studies were considered who? If they were noble, who were they? The kings and queens, princesses, right? All those people were considered the nobles. They're still considered nobility. In England, they're still a queen. She is noble. Okay? They're still princesses. They're noble. They're nobility. Okay? Now think about it. Do those people ever mix with regular people for the most part? For the most part.
No.
Obviously not, but truthfully, if you think back then, do you think the king would go out and like just hang out with a peasant? No. No, why? Because they think they're better than them, right? They're nobility. They have money, and they're not going to go hang out with a peasant. Okay? So, think about these as the kings and queens. They don't want to mix with anyone else because they're better than everybody else. Or they think they are. Okay? So these are called the noble gases because they don't mix with anyone else. They're stable. They don't need to. Okay? Now, all of these are reactive. These are most. But all of them are reactive. They're not stable. And they mix with each other. Okay? So, any questions up to this point? Alright. Now, last thing we're going to talk about is what we call Lewis dot diagrams. Lewis dot diagrams are basically a shorthand way to give elements and their valence electrons in a short format. So instead of saying helium has instead of writing that down, helium has one valence electron, you would write a shorthand way of doing that, which is a Lewis dot diagram. And the Lewis dot diagram just basically uses a symbol and dots to represent valence electrons. So, H is the symbol for hydrogen. Hydrogen with a dot on it tells you that hydrogen has one valence electron. So, neon has how many? 8. 1, 2, 3, 4, 5, 6, 7, 8. So if I give you this, you don't even have to look at the periodic table. Well, you do if you don't know the symbol. But other than that, you have the number of valence electrons, right? This is the symbol for aluminum. So how many valence electrons does it have? 3. Okay? So what I want you to do is I want you to draw me the Lewis dot diagram for calcium and phosphorus. So draw the Lewis dot diagram for calcium and phosphorus. So you need to find out first the symbol for calcium. Then you can look at the group to tell you the number of valence electrons. And then you draw the dots. And then you find phosphorus. Find the symbol for phosphorus. Look at the group. And then you draw your dots. Usually if you look, you start at the top, okay, and then you go yourself around, and then you continue yourself around. So you kind of start at the top and then go around.
Oh, don't just wait.
Sorry, yeah, just wait. Are you done? Both of them? Yeah, we're going to use you as an example. Okay, so we think got it? Let's check ourselves with Alfredo's work. So Alfredo, will you put yours up here? Oh, wait a minute. Thing's on. I'll do it. Alright, so if we look, so here it is. So Alfredo's saying that the symbol for calcium is Ca, and then it has 2 valence electrons. Is that correct?
I wrote 20.
I know.
But remember, it's valence electrons, not total electrons. Alright? Now, for phosphorus, he's saying the symbol is P, and it has 5 valence electrons. Is that correct?
Yes.
Yes. Okay? So these are fairly simple. You're just writing the symbol, and then just putting your dots around. Any questions? Okay, now, we are going to do an activity to kind of look at all these and kind of make sure that you know how to pair these up. But before we do that, I want to set up tomorrow's class, because tomorrow I will not be here.